Okay, 2 by 2 matrix here. Firstly I want to find the determinant of that matrix. So the notation for the determinant of a matrix, if that is A, then the determinant of A, that's two straight lines. That's the symbol for determinant of a matrix. And to calculate it, it's the leading, multiply the leading diagonal, so 6 times 2, take away, and then I multiply the backward diagonal, 1 times 3. So that's 12, take away 3, which is 9. Second one, same here, that's B, and the determinant of B is that, and to find that determinant is the leading, so 6 times 1, take away 2 times minus 2, so that's 6, minus 4, which is 10. Okay, so in general, if a matrix is A, B, C, D, that is A, then the determinant of A is AD minus BC. AD minus BC. Okay, so moving on to find the inverse of a matrix. Now then, to find the inverse, okay, it involves the determinant, but it also involves swapping the numbers around. Okay, so if I have a matrix A, B, C, D, that's A, then the inverse of A, which I denote by A to the minus 1, is equal to, it's 1 over the determinant of A, and then I interchange the A and the D and change the signs in the other diagonal for the B and C. So that's how I find an inverse. So for this one here, look up the determinant first of all. Let's call it A. So the determinant of A is AD, 5 times 2, take away 8 times 1, which is 10, take away 8, which is 2. So the inverse of A is 1 over the determinant, so half, and then interchange the 5 and the 2 and change the signs in the other diagonal. So that's the inverse. Now then, what an inverse does, if I multiply a matrix by its inverse, so A to the minus 1 times A, so half, 2 minus 8 minus 1, 5, times 5, 8, 1, 2. Leave the half there for the moment. If I multiply this out, cross and down, 2, 10, take away 8 is 2, 16 and 16 is 16 minus 16 is 0, minus 5 plus 5 is 0, minus 8 plus 10 is 2. That half change, I have all 4 entries in that matrix, which is 1, 0, 0, 1. And that matrix is what we call the identity matrix, which has the effect like the number 1 in our number system. So I'll just do this second one. So I'll call this one B. So the determinant of B will be 3 times 8, take away 2 times 11, so it's 24, take away 22, which is 2. So the inverse of B is 1 over the determinant, which is 1 over 2, interchange the 3 and the 8, 8 and 3, and change the signs in the other diagonal, that's minus 2, minus 11. And to check it, I will check B minus 1 times B, that's a half of 8 minus 2 minus 11, 3, times B, that's 3, 2, 11, 8. That's the half of, right, crossing down, 24 take away 22 is 2, 16 and minus 16 is 0, minus 33 plus 33 is 0, minus 22 and 24 is 2. a half will halve all 4 entries, 1, 0, 0, 1. So I know, because I've got the identity matrix and I've multiplied a matrix by its inverse, that's correct. Okay, application of this then is to solve pair simultaneous equations, and then I can rewrite these equations in matrix form. So if I take the coefficients of x and y, so that'll be 4, 1, 3, 1. If I operate that on x, y, that would equal 6, 5. So that's the matrix equivalent of those equations. And then first job is to find the inverse of 4, 1, 3, 1. Let's call this A. So the determinant of A is 4 times 1, take away 3 times 1, which is 4, take away 3, which is 1. So the inverse of A is 1 over the determinant, so that's 1 over 1. Change the 4 in one round, 1, 4. Change the signs in the other diagonal, like that, and because it's a 1 outside, all the entries will stay the same. So that's the inverse. So I'll call this A, matrix A, which I did earlier. I'll call this my general vector X, and this column vector can be B. So I'm solving AX equal to B. So what I'm going to do is pre-multiply both sides by the inverse. By the inverse, so I get a to the minus 1 times A on the left hand side is a to the minus 1B. And when I multiply a matrix by its inverse, I get the identity matrix. And when I multiply anything by the identity matrix, it stays the same. It's like the number 1. So X will be a to the minus 1B, and it's X that I want to find. So X will be the inverse, which is 1 minus 1, 3, 4, times B, which is 6, 5. So that's XY. Multiply that out across and down. So that's 6 and minus 5 is 1. 18. Oops, minus 1, minus 3 there, sorry. Minus 18 and 20 is 2. So that gives me the answer of X equals 1 and Y equals 2.